So this packet has what I would call the Algebra 1 concepts that go with linear equations. You're going to see some things repeated that we did in Unit 3, but then you'll see quite a few things that are brand new that go with that high school Algebra 1 stuff. So if you didn't already, put your name on the front, so if I find your packet, I can give it back to you. And then once you did that, I am on just the inside cover page to kind of put some things that we already know and then some big picture things that we are going to know on linear equations. So I'm just on the back of that front cover on that big blank page. You guys are writing this down too. Linear equations, kind of what we know and what we need to know for linear equations. First of all, linear equations are anything that if I graph it, it makes a line. We already know that from Unit 3. In Unit 3, we saw one main form of linear equations. We were calling it slope-intercept form a little bit. Or you saw it in the form y equals mx plus b. And I'll come back to that, but first I'm just kind of making a list. Slope-intercept form is probably the most common, the most well-known. 8th grade students should learn the basics of slope-intercept form, and then algebra students use it in more depth. We grazed the surface of standard form. Standard form really is the equation that would have been best suited for problem 7 on the test that you took yesterday. So those of you who are like, I wasn't really sure on what type of equation to write there, it's because we didn't spend a lot of time on it. Standard form is in the form ax plus by equals c. And again, I will explain what that means once we have all of them to look at. In high school Algebra 1, probably the most common one that you spend time on is point-slope form. Point-slope form is used in a variety of ways for other things in algebra, geometry, other upper levels of math. So even though slope-intercept form is the most common, point-slope form is like a close second for how often you would need it and to use it. This is what point-slope form looks like, and then we'll get into it more in the notes. It is y minus y1 equals m times the quantity, so parentheses, x minus x1, parentheses. Each of these linear equations all have an x and a y in them. That's how we know that if we graphed them, they would make a line, because there's an x and a y that represents a bunch of points on a line, like we learned in the last unit. Then each form is used differently depending on what information you have or possibly what information you need. We already know that slope-intercept form, the m gives us the slope, the b gives us the y-intercept, or where your line crosses the y-axis. So slope-intercept form gives us those two pieces of information. Standard form, these A, B, and C letters just represent some numbers, positive or negative, they just represent some numbers. And it being called standard form is always like my hint that doesn't give you anything. Like slope-intercept form gives you a slope and a y-intercept right from the equation. But you use standard form to find two pieces of information, the x-intercept and the y-intercept. And so we'll talk today about how you get those. Some of you already kind of know that from things that you saw in lesson 13 and 14 in the review, but some of you didn't quite grab that yet. Point-slope form also gives you two pieces of information. If slope-intercept form gives me the slope and the y-intercept, what two pieces of information do you think point-slope gives you? A point and a slope. So it's nice because the title of it tells you what you're given. We already know from slope-intercept form, what does the m stand for? Slope. So it gives us the slope in front of a set of parentheses, which we'll get to and talk about. And then this part and this part, this y1 and your x1, not the regular y and x, but the x1 and y1 give you a point. So similar things to slope-intercept form. They both give you the slope, but specifically slope-intercept form gives you a point on the y-axis only, versus point-slope can give you any ordered pair point that's on the line. So that's like the overview of the three types of linear equations. Again, we know slope-intercept form enough from what we've done. Standard form we need to do more with. Point slope you haven't seen exactly, but we have done some things that connect to it, and I'll show you that when we get to that part in the notes. Today, my goal is to do a little bit on standard form and a little bit on point slope form. And then tomorrow we'll spend time just graphing the three different types that we have. So I printed this just based off of a homework assignment that I've done in prior years. It's not homework. I'm using it as notes to kind of show you where standard form comes from. So the one that we're starting with is the one that's ax plus by equals c. The one that technically you saw a little bit of when we did like the pineapples and avocados problem, but we just didn't do it enough. So I'm using this as notes, so like if it helps to kind of watch me do something and then try it with me, like feel free to watch me because there's a lot of pointing when I'm doing graphs. I'm using number 1 just to give you a quick visual. If you sketch like a little mini coordinate grid right here, and you look at what happens when I look at these two ordered pairs, for a line that passes through the points 0, -7, and 3, 0. So look at this. Over 0, down -7. I'm going to say it's about right there. I don't know if I counted exactly, but it's on the y-axis. So over 0, down -7, and over 3, up 0. So for a line to pass through those points, you can see that there is an x-intercept on the x-axis of 3, that was over 3 up 0, and there's a y-intercept on the y-axis at -7. You guys know from plugging in points in lessons 13 and 14, if I give you an x to plug in of 0, it can solve for your y. If I give you a y to plug in of 0, it can solve for your x. So you already know some of this, and when I show you some of the math that connected with it, hopefully that'll spark your mind. Just going through a little bit of each of these, and then I'm doing some of the math. 3, 4, and 5 say identify the x and y intercept. So if you are identifying the x and y intercept, that vocab just literally means where is your line crossing the x-axis? Well, it's crossing the x-axis at the point over 3, up 0. That's all that's asking. The y-intercept, where is my line crossing the y-axis? Well, that point would be over 0, up 2. So the big thing to see is that when you are dealing with a line that intersects the x and y axis, your ordered pairs have a 0 in them because they're on the x or the y axis. So if we looked at something like number 6, my x-intercept is 4, 0. Well, even without them telling me that, if I graphed over 4 up 0, and I graphed over 0 up 5, you are drawing a line with those intercepts. It's a quick sketch. You guys have a straight edge if you want to use the protractor. I'm just kind of sketching them. So standard form, when we turn the page and start getting to the equation, standard form is not using the slope. Standard form is not finding the y-intercept only. Standard form gives you the x-intercept and the y-intercept, and then you just have a quick graph through those points. So turn the page. We're going to do a couple of these, and I'm starting on 14 just because I like that all of the numbers are positive to see that first. You guys did in lessons 13 and 14, we did problems where I gave you an x value and you solved some math work and got the y value. Or I gave you the y value, you plugged that in, you showed a little bit of work to get the other value. That's all I'm doing here, except I'm plugging in 0 because 0 represents a point on my x and y axis. So I do have to do 2 problems. So one of my problems, I'm going to plug in 0 for x first. So 4 times 0 plus 3y equals 24. And for the first time doing this, I'm showing all of my work. Most of you, probably even by the end of class or end of class tomorrow, you will shortcut this work. If I plug in 0, what's anything times 0? 0. So that essentially just cancels out, not that you have to rewrite it, but really all that you have left is this tiny mini equation. When I divide to solve for y, just like we did at the end of the last unit, what would my y variable be when I do 24 divided by 3? 8. So what just happened is I plugged in 0 for the x coordinate. I got 8 for my y coordinate. We know this from the unit as a solution to the line. So is this a point on the line? Yes, because I just plugged in and found it. And specifically, over 0 up 8 is my y-intercept. So I found one of the intercepts. Then I go and I do basically the same thing, except instead of plugging in 0 for x, I'm now going to go into the equation and plug in 0 for y. So I have 4x plus 3 times 0 equals 24. And again, as you get into this, you're probably not going to show every step, but what's anything times 0? 3 times 0 is 0. So that cancels out. So all that's really left in my little mini equation is 4x equals 24. If I divide to solve for x, what's my x-intercept? 6. And again, what just happened was we plugged in 0 for the y. When we solved for x, it gave us 6. So over 6 up 0 is the x-intercept. So I found my y-intercept, I found my x-intercept. I have a little sketch of that linear equation. Questions so far? Okay, I'm going to scoot over to 13, and I'm just going to kind of talk through 13, but those of you who I already know don't like to show a lot of work or can do things in your head, watch me think through this. And if you learn best from watching, just watch me because I'm not writing a lot. If I plug in 0 for x, what's 4 times 0? 0. A lot of teachers call standard form the cover-up method, because if you cover it up to kind of pretend it's not there, because I plugged in 0, it's gone. How would I get y by itself? You would divide by 5. And when you divide by 5, my y would be negative 20 divided by 5 is negative 4. So there's my y-intercept. Now that I plugged in 0 for x and let my x cancel out, I'm plugging in 0 for y. 5 times 0 is 0. Pretend it cancels out, so I'm covering it up so it's gone. I would divide by 4 to get my x by itself. And what's negative 20 divided by 4? Negative 5. So my x-intercept is negative 5. My y-intercept is negative 4. There's my quick sketch of that graph. That's me showing no work. So like many of you aren't there yet and you're like, whoa, you just did too much without showing anything and you lost me. That's fine. Most likely between today and tomorrow, you'll be somewhere in the middle with showing whatever amount of work you want. See if you can try number 15, given what I showed you. If it helps, look at what I did on 14 and I showed a lot of work. If you're kind of like, I think I can do this quicker, then sketch it out. The nice thing is linear equations, you don't have to show work. Your graph is your work. So your answer is the graph. So me showing work is just for people like me if I need to show my work. I'm not giving you any assigned homework today, but I'll encourage you with whatever time is left in class to try the other ones too. So I'm going to go over 15 and then you can try 10, 11, and 12. Ultimately, tomorrow we're trying more of these. So whatever time we have left, you can try a couple more. Here's me showing all of my work again. 2 times 0 minus 3y equals negative 18 is going to be one of my equations. And then 2x minus 3 times 0 equals negative 18, running into my hole punch, is going to be my other equation. Ultimately, I'm plugging in 0 for x to solve for my y-intercept. And I'm plugging in 0 for y to solve for my x-intercept. From there, see if you can take a little bit of a shortcut. Like something else I like to do is where I'm multiplying by 0, that cancels out. So just cross it off, it's gone. And then those of you who are like me and you like showing a little bit of work, if I'm getting rid of that negative 3, I just need to divide by negative 3. Some of us benefit from showing just that tiny step. And then I can see easier, negative 18 divided by negative 3 is a positive 6. So my y-intercept is positive 6. Sometimes you'll see it like this when you're talking about the intercept. Sometimes you'll see it as ordered pairs with 0. Same thing. If my 0 cancels out over here when I plug in 0 for y, all that would be left is dividing by 2. So my x-intercept, negative 18 divided by 2, is negative 9. So my x-intercept, way over here at negative 9, there's my little quick sketch of my graph. So on that problem yesterday on the test, you might have found an easier time graphing those intercepts to get your whole graph, but some of you graph the combinations, and that works fine. But some of you couldn't think about the combinations into an equation. This would be like the hot dogs and candy problem. $4 for a hot dog. Now we're at an expensive baseball game. Plus $3 for candy. I have a total of $24 to spend. So that's what connected back to the problem yesterday, that last problem of the test. Okay, we'll do more of those tomorrow. Turn the page. Then I'm spending the rest of the time on point-slope form. So point-slope form, we wrote on that first page what it looked like. So let's write it here so that we can see more of what it means. Y minus y1 equals m times the quantity x minus x1. First, a little like side note, and again, I am on to a completely different form of a linear equation. This has nothing to do with standard form because point slope gives me a point and a slope. Earlier in the year, in fact, it was on the test for Unit 2. I think it was the second to last question on the test for Unit 2. You had a graph and you had to write an equation of a line. And your equation of the line, if I just use this information, and you don't have to write this down, but just watch. Your equation at the end of Unit 2 was y minus a y coordinate from a point over x minus an x coordinate from a point equaled the slope. Do you remember those a little bit? Now that you guys have learned more with slope, slope is the vertical change over the horizontal change. We did one day of finding slope from points. Remember when we were subtracting the coordinates, like y minus the y coordinate over x minus the x coordinate? Because we were finding the change in y over change in x, same thing as the vertical change over the horizontal change. Now this equation should make more sense. Y minus a y coordinate, this is just showing that horizontal or that vertical change, that change in y. X minus the x coordinate is showing that horizontal change. So really what this equation says, if you asked any math teacher, this is slope equaling slope. Like if I called it a formula, this is the slope formula equaling the slope answer. So all point slope form is, just watch me, because again, you don't need to know this perfectly. If I got rid of this expression on the bottom, and you see how it's being divided, so the opposite of dividing is multiplying. So if I got rid of that by multiplying and did the same thing to the other side, that's point slope form. Y minus a y coordinate equals the slope times x minus the x coordinate. So it's just taking one type of linear equation, but writing it all on one line just because that's typically easier for math. So it's simplifying it. The most difficult thing in point slope form, I'm saying this slowly, is that the way the formula works, it comes from the change in y and the change in x. And in math, we find change by subtracting. So this minus sign does not mean that this x coordinate is negative. It actually means that this x coordinate is positive, because think about it. It's x minus an x coordinate, and it's y minus a y coordinate. You'll see that as I go through a couple of these, but just a warning that that minus sign is always what throws my students off. So the first part is pretty straightforward. We're going to write an equation in this point-slope form that passes through the given point that they give us and has the slope that they give us. So kind of like I just did on the top, but I went in a roundabout way, I would literally do it like this, and just watch me first, because we'll do a couple of them. Y minus the y coordinate of 7 equals the slope, my m, of -4, times the quantity x minus my x coordinate of 2. Is my 2 or 7 negative? No, but do they kind of look negative in the formula or in the equation? So you have to be careful about that. That minus sign is part of the linear equation. This is a +2 and a +7. Okay? Fill in my blanks. Y minus, what's my y coordinate? 5. Equals my slope. What's my slope? My m. So -3 times x minus my x coordinate, 12. And again, if it helps, label it. This is my x, this is my y, my m is my slope that goes in front of the parentheses. Try writing number 3. Something slightly different in number 3, but try not to let it throw you off. So jot down your point-slope formula equation for number 3. Because there's a negative point, there's technically 2 ways you can write it. The more you say this type of linear equation in your head as you're writing it, the easier it's going to feel. So like as you heard me kind of saying y minus the y coordinate equals the slope times x minus the x coordinate. Kind of say that in your head as you're going, or y minus y1 equals m times x minus x1. So number 3, y minus my y coordinate. So at first, I'm hoping you either thought or wrote it like this. Y minus the y coordinate equals the slope times x minus the x coordinate. Totally good, totally fine, totally acceptable. But what do you think I would say you should simplify? Kyle?
Y plus 5.
Yeah, really minus negative, if you hear that coming or if you wrote that down, it should be simplified to y plus 5 equals 6 times the quantity x minus 4. So write one more. Write out your equation for 4, and then we're going to look at some of the graphs. And then we're done. So you're saying in your head, y minus the y coordinate equals the slope times x minus the x coordinate. And you could write it out and then change it to plus, up to you. So y minus -2 is really y plus 2 equals my slope of 3 times x minus -6 is really x plus 6. So before we do the next problems where we're graphing, hugely important to see again, so just look at what I'm pointing out and highlighting. I had a positive point here of 2, 7. +2, +7, because it comes from after that minus sign. I had negative coordinates here, -6 and -2, but they're written as a plus sign. So that's where your brain has to go the other direction. And remember that this is actually x minus -6, and this is actually y minus -2 to get my point as a -6 and a -2. Are we seeing that? Because then I'm going to mess with your heads when we go to number 7. Okay. Now we're just starting the graphing of these. And again, we're doing more graphing tomorrow. So today's like, see if you get it, try a couple, and then we'll do more tomorrow and see if we're getting it or if we need more practice. You need your two pieces of information. Just like slope-intercept form gives us our slope and our y-intercept, these ones give us our point and our slope. As we go into it, you don't have to show any work. You could just put those two pieces of information on the graph. Your graph is your answer. But be careful. What is my x coordinate? 2 or negative 2? And it plays with your head until you catch on to it. But my formula is x minus the x coordinate. So if you don't have a minus sign there to grab the point from, you either need to picture it or write it. I suggest writing it as minus negative 2. Your x coordinate has to be grabbed from after a minus sign. So your x coordinate is a negative 2. And again, if you look back at the examples that we wrote up here, where we had that happen with these negative coordinates because we tried to write x minus negative 6 and we wrote it as plus 6. So given that, what's my y coordinate? Positive 4 or negative 4? Negative 4. And I can see it in your eyes. It's messing with your head. So be like me. Sometimes be like your teacher. Rewrite it just so that you can see it. And then compare that to what the formula or the format of the equation says. Y minus the y coordinate. The y coordinate is after that minus sign. It is not the minus sign. So when I have y minus negative 4, that negative 4 is the y coordinate. Thankfully, the slope's easy to grab. The slope is always just hanging out in front of the parentheses as a negative 3. Which piece of information do you think I use first, the point or the slope? Where do I start? Yep, Brooklyn or Chaley. Yes, the point. Just like slope-intercept form. Remember how we started on the y-axis? So Chaley's right. So start here. This is my xy point that I pulled out, so I can start there. Over negative 2, sorry, there's no numbers on here, but we'll survive. Down negative 4. That point is my starting point. And since these are my notes, it might help you to label it, but if you don't need that, you don't have to. But just in case you look back at where did that come from, that's our starting point. Our slope is our vertical change over our horizontal change, so I suggest writing it as your vertical change over your horizontal change, so I put that 1 on there. So I need to go vertically 3 and horizontally 1, and I need a negative line. So if I start going vertically 3, I need to think about if I go this way, that's going to have a positive slope. I don't want to go that way. So vertically 3, but to the left 1, if I sketch that, that's going to have that negative slope I want. So there's my negative sloped line. So graph your point, use your slope to make another point, and there's your whole linear equation graphed. All right, see if you can pull your point and your slope out of number 8. And again, if you're a little ahead of me, do a couple other ones. Don't go too fast, though, if you're not 100% confident, because these are the ones that your brain plays tricks on you. You have to think, is that 2 a positive or negative, and is that 3 a positive or a negative? And again, your coordinates are coming from after a minus sign. So y plus 3 equals negative 2 times the quantity x minus 2. What's my x coordinate? 2 or negative 2? 2. Because after that minus sign is my x coordinate. So it is a positive 2. What's my y coordinate? 3 or negative 3? Negative 3. And again, rewrite it if it helps, especially because these are our notes and this is the first time we're seeing it. That negative 3 from after the minus sign is my y coordinate. So your starting spot is over 2, down negative 3. And again, I'm just labeling it for my notes so that you remember that that was your starting spot. Otherwise, you don't have to label that. My slope is negative 2. So I have to have a vertical change of 2 and a horizontal change of 1. And again, I need a negative sloped line. So I have a vertical change of 2, a horizontal change of 1. If I went right here, that would be a positive line. So I went the wrong way. So vertical change of 2, horizontal change of 1. There's my negative sloped line. Okay. So, not trying to give you homework on Halloween, so I am asking you to use the rest of your class time wisely. And what I would like you to do, we're not going past these unless you want to try to check them out, but I want to focus on like one topic at a time. But if you can try writing the equations for 5 and 6 and graphing the lines for 9 and 10, and going back to standard form and sketching some of the intercepts for 10, 11, and 12, don't go back to the first page. Just this page and this page. Try a couple of them. See how you do. Work with a friend. Talk about it. Ultimately, tomorrow is going to be a mix up all the types of graphing, including slope-intercept form and the x equals and y equals, special case vertical and horizontal ones. And we're just going to practice, because if you are in Algebra 1, you are an expert at graphing all types of linear equations. So tomorrow's mostly just a work day. All right, go try those last few. So these 4 that are on this page, these 3 that are on this page.